Hey everybody, welcome back. We are going to, in this video, start creating a second microservice. We're going to create our inventory service. The whole point of that is for creating that early on, even though we haven't really fleshed out the catalog service, is to show how integrations work between the two microservices. So I wanted to get to that quite early because it's an important concept within the microservice world. So just to sort of foreshadow what we're going to be doing here, in the catalog service, what we've already done is create the ability for callers to create products, update products, and get products by ID. What we want to do is anytime a new product is created or updated in the catalog world, we want to notify the inventory service so that it can start tracking inventory for that product. So that's the main goal that we want to do here. We're not going to actually do the integration here, but we're going to create the microservice in preparation for that integration. So I'll start it off by actually creating a solution folder for our inventory service, and we want to start with our domain layer. So we're going to create a new class library. We want to put our class library in a new folder here on disk for our inventory service, and this will be our inventory.domain. All right. So within our inventory domain, what we are going to focus on is just the products again for now, and we want to track inventory for the products. So we're going to create a products folder, and right in here we're going to create our domain entities. So we're going to end up having a product aggregate root in our inventory domain, public class, and what we're going to be doing is, so in the catalog world, what we had is these objects are created by requests coming in from clients to create or update. So a calling client app like a web app or etc. would be calling into the API to create them. The difference is, in the inventory world, we're not going to accept from client calls the ability to create products. Instead, that information is going to come from the catalog. So when a catalog service, when a new product is created, it's going to notify the inventory domain, and therefore when we create a product, it's not going to be coming from an end user, it's more so going to be coming from another microservice. So what we want to be able to do, though, is with our product in the inventory world, we do want to track inventory, but let's say that one of the requests we want to support in the inventory microservice is, get the current inventory level for product XYZ, where XYZ is the product code. So let's open up our product here just to refresh our memory of what it looks like in the domain of the catalog world. So if we want to look it up by the code, we're going to need the code stored in the inventory microservice. The reason for that is that we don't want any queries that we have to run or any response objects that we want to build from the inventory microservice to have to call out to in real time to the catalog microservice. So one of the big rules here is we don't want dependencies between our microservices. That could be because the catalog service is down for some reason. It could be because of maintenance. It could be because of unplanned maintenance, some sort of outage, a bug. And we don't want to necessarily let that bring down the whole inventory service if the catalog service is unavailable. So microservices will communicate using events, not direct calls. And so in order to be able to respond to that query, we need the code stored in the inventory database. And we're going to store it, so we are going to duplicate data, which, a lot of us have been trained to think that duplicating data is a very bad thing. And it can be in certain situations, but in the microservices world, it's quite common. So what I'm going to do with our aggregate root here from the domain of the catalog world is actually bring it over as is, because one of the questions you want to ask is, well, how much of the data that we're bringing over from the catalog world do we actually want in the inventory world? And I think there's a case to state where we might want the code, the name, and the description. So there might be a case where we don't need the description and we can drop that. But for this example, I'm going to keep all of it. So now we have an aggregate root, also called product, in our inventory domain. And one of the key differences, as I mentioned, is we're going to be getting the product from events. And when we get the event, the product will have already been assigned an ID in the catalog world, and we want that same ID to be used in the product world. Sorry, in the from the catalog world in the inventory world. So we're going to be using in our constructor an ID that comes from the event. We're not going to assign it an ID upon creation. Therefore, we're passing that in, and we're going to paste that to our base constructor as well. So we've got the basics here of what we want our product to look like in the inventory world, but we also want to be able to track stock levels. So what we want to do is we expose a list of, I'm going to use an object called stock adjustment. We haven't created that just yet, where it's going to be a read-only collection. So one of the principles I like to stick to is non-anemic objects, and also force, from a domain-driven design perspective, force users to use the aggregate root to talk to child objects. So we don't want them directly calling the add or remove methods on this collection. So we want to expose it as a read-only list. So I'm going to use a read-only list for exposure, and what I'm going to expose is an internal version of the list. So I'm going to have a private read-only list of stock adjustments. And then this is just going to be exposing it as a read-only list. We'll initialize that to an empty array. So again, what we're trying to do here is make sure that callers are not directly calling add and remove on our list, and therefore we're going to expose our list as a read-only. But that also means we need a way to give the user the ability to add items to the stock adjustment list. First, let's actually come into our domain though and actually create our stock adjustment object. This is going to be a value object with just two properties. We can have a decimal, which is going to be the amount that we're adjusting the stock by, and then we want to track the date and time adjusted. And as I said, that's going to be a value object. And we need a public there, so this is going to be a public value object. And we need to implement our equality override, which is just going to be yield return. We're going to, if the amount matches and the date time adjusted matches. So that's our stock adjustment, and we're going to keep a list of those in our product. Therefore, the current stock level at this very moment is just going to be the summation of all of these. So if we add up all of our stock adjustment records, that'll tell us how much we have in inventory of that particular product at that given moment. So we need a method by which they can add stock. So we're going to have an add stock method here, and stock adjustments.add. We're going to create a new adjustment record, and we're going to set the date time adjusted to the current UTC time. So that's pretty much what we have. Now, we again might want to flesh this out in the future to add more functionality to our inventory version of the product, but for now, this looks good. Now, one other thing we got to take into account is using MartinDB as our CRM, or ORM, sorry, as our ORM to store data in our PostgreSQL in a NoSQL way. We are serializing these as JSON. So what we need to do is, if we left this as is, when it goes to hydrate an object from the database, it's going to try to fill in the stock adjustments property, but there's no setter, and it's read-only, so it's going to fail. So we need to inform our serialization about how to do that serialization. And what we want is a JSON property here, and we're going to have to bring in a reference to Newtonsoft. What we want to be able to tell it here is, hey, this list here, the internal read-only version of it, is the one that we want to be moving in and out of the database. So when you're hydrating and you're pulling data to put into the database, this is the property we want you to actually reference, not the read-only one. So this has no impact on our end users. It's just literally for how does it get serialized in the database. And then one last thing we need to do is tell it to ignore the read-only version. So now stock adjustments, the private property, is what's going to be used to move things in and out of the database for that particular property, stock adjustments. So we got that all set. So we're good with our domain objects, and so what we need is our repositories, and this is going to be pretty straightforward. We're just going to have a iProduct repository, and that's going to inherit from a different interface. That's going to inherit from our iRepository for product, and we're good. So we got our repository. Now we need some DTOs. DTOs we're going to expose. In fact, I'm going to save some typing here because the DTO we're going to expose is going to be very similar here. Just got to remember to change my namespace there. So we're going to end up with exactly the same thing. The only additional thing is we're going to have a list of stock adjustment DTOs. I haven't created yet. So we can pull in our stock adjustment DTO. And this guy's just going to have two properties. Which is going to be our decimal field for amount. And then our date time adjusted. Alright. So we've got our DTOs, we've got our repository, and we've got our domain object. So we're good with our domain layer, and we can move up a layer now. We're going to now work on our infrastructure layer. So it's going to be another class library. We want to put this in our inventory service. And this is going to be inventory.infrastructure. And we're going to start off by creating a products folder. Alright, and then what we need in here is we're going to end up with some queries, and we're going to end up with repositories. Normally we would also have in here commands, and commands again are for changing state. All I want to do for example purposes for now, so for instance, we don't want commands to create and update products in the inventory layer because that really is the responsibility of the catalog. So over in the catalog world we do have commands here for creating and updating a product, and that's where it should happen. So we're not going to accept a command in the inventory world to create a product because that's the responsibility of catalog, and catalog will let the inventory service know when that happens. What we do want to support though is the ability to retrieve a product from the inventory world. And so the good news is our get product by ID, which is exactly what we want to support, is going to be verbatim what we already have in the catalog world. The only difference being that we're pulling out our inventory versions of the products, which is also going to have the stock adjustment pieces. Let me not delete that actually. So we need to update our namespaces, and then we need to bring in some dependencies. So we need to bring in mediator. We need to bring in our domain layer for inventory. We want to make sure we pick the right one here. So this is the inventory world. We want the inventory domain. The inventory microservice will have 0 references to anything in the catalog world and vice versa. There should be no dependencies between microservices. We need to bring in AutoMapper. And the good news is we're actually done here, because what are we doing? We're going to receive a request where user is passing in the ID of the product to retrieve. We're going to respond with our get product by ID response, which is inheriting from our product DTO. And in the handler, we're going into the repository, getting the product by its ID, and then using AutoMapper to map that product over to our response object. So we're actually done with our query handler there. And our repository is actually going to be really straightforward as well. So this is going to be our product repository. and public class again, and this is going to take an IUnit of work and an IUser session, and it's going to rely on a base class for product, and then it's going to implement our iProduct repository. We've got to bring in a few more dependencies here. We want to bring in a reference to our shared infrastructure. That's where the repository is coming from. And then here we want to reference our domain layer. And we want to pass in to our base class the unit of work and user session. And voila, our repository is done. So we get a lot of the rich functionality we need, such as insert, update, and get within the base class. So we don't have to implement very much in the concrete class here unless we want to add additional methods. So I should mention real quick too that we will be adding commands eventually, right? Because we want to add in our inventory microservice the ability to update the inventory levels, but we're just not going to do that just yet. I again want to sort of get to the integration piece of this all between the microservices to focus on that. So we'll come back to the inventory service and make it richer later. But for now, we're good. Now, there's a couple more things we need to do in our infrastructure layer. And so what we saw already is we are going to put right in the root of our products folder here, we're going to have a class that's going to tell AutoMapper how to wire things up, what we want auto-mapped. So we're going to have an AutoMapper here, and this is going to inherit from from profile. And we're just going to override the constructor. And within the constructor here is where we're going to create our mappings that we want AutoMapper to perform for us. So we're going to go from a stock adjustment to a stock adjustment DTO. And we're also going to want to map from a product to a get product by ID response. All right, so that's our AutoMapper. And one other class we need in the root here is going to be telling AutoFac, our dependency injection library, what dependency injections we want. So we can call this our products module. And we are going to inherit from module coming out of AutoFac. All right, and then we just need to override the protected load method here. And then in the load method, we are simply going to register our types. So we're going to say register type product repository. So anytime somebody requests an iProduct repository, we are going to return our concrete version, the product repository. All right, so we got all that wired up. So our infrastructure layer is done. Now let's go ahead and add our API project. So we're going to start with an empty .NET Core. Again, placing it in our inventory service folder. And this is going to be inventory.api. All right. Now, again, the good news is a lot of the microservices are going to have a very similar program CS. We want to do a lot of the same functionality. We want to have health checks. We want to authorize the call by looking at the JWT coming in and authorize that against Firebase. So what I'm going to do is copy all of this directly over to here. And one of the first things I want to resolve is our dependencies. So if we look at the dependencies that we want to bring over from, we want the same dependencies that we have over here in our catalog microservice. So we want our AutoFac extensions dependency injection. Install that dependency. And then we want our AutoMapper contrib library, which integrates AutoMapper with AutoFac. And then we want Firebase admin. This is being used to authenticate and verify our JWTs. And then we want Microsoft ANA Core JWT library. Oh, that's going to fail actually, sorry. Let me just decline that. Because we're using .NET Core 8, I can't yet use the 9 library of that. So I'm going to use the 8 version. Alright, and then finally we want Swashbuckle ASP.NET Core in order to add our Swagger support. Alright, now we also need a couple project references. So here we are in the inventory world. We want to reference our 2 inventory libraries and then the 2 shared. Alright, now if we come all the way back here, we should have to update that to inventory, which gives us our product. Looks like we have an extra using statement there. Why is it not recognizing our Swagger? Apologies, one sec. There's a slightly different library that we should be referencing. So Swashbuckle ASP.NET Core is what we want, not the one that ends in .swagger. There we go. So the one that doesn't end in Swagger. Alright, there we go. That should fix our reference here in a second. Yep. Alright, so what are we doing in here? Again, just to review, we are health check, adding JWT authentication support, adding cores, adding Swagger, generation of APIs, and then controllers. The other thing we need to bring over is our JSON file, which passes in the config information to our Firebase world. So we'll copy that over. Overriding using AutoFac as our dependency injection library, and then we are bringing in and registering through for AutoMapper purposes our products module, and then we want to reference a shared and products module. Now again, these product modules are very much similar to what we saw in the catalog world, but they are the inventory versions of them. We're going to add our health checks, we're going to start up a user session, and so yeah, everything here looks good. Next we want to add a controller. So we'll add a controllers folder, and again I'm going to cheat and bring over our products controller from the inventory world. And as we talked about, the difference is we're going to have a get by ID, but there is no create and update. So in other words, there's no commands as of yet. So we can get rid of that using, and then we can get rid of our 2 methods here. Alright, now a couple things I wanted to clean up here. I want to check and make sure that our both projects, I'm going to check both projects here in the debug settings. Make sure that we have it set up to open up Swagger upon startup. So the very first URL we want it to hit is Swagger. So we're going to do that on both projects here. And then another thing we're going to take a look at is making sure that both projects are set to start at runtime, so our debug time. So we're going to go into the properties of the project, go to multiple startup projects, and we want to make sure that the catalog API and the inventory API are both set to start. So when we hit debug, both projects will actually start. All right. One last thing, I believe, which is I need to bring over my connection string. So I'm going to temporarily just take this over here and copy over the connection string. So as a reminder, the connection string, so each microservice has its own database. So the catalog microservice has a database I'm just calling shopping.catalog, and our inventory microservice is in the same database server. It doesn't have to be the same database server, but I'm developing locally, so that's just what I'm going to use. In our same local one, I'm going to have shopping.inventory as the database. So I updated my connection string in our app settings development JSON. And so I think we can go ahead and see if this is ready to compile and if it will fire up. And if it does, we should get 2 Swagger endpoints, one for each microservice. And there's one, and here's the other. So here's our catalog API, which again we have get, put, post, and then we have our get for the inventory world. Now normally at this point I would start writing some Postman tests to test out this new endpoint that we just added to the inventory API. However, we don't have anything in the database yet, so we can't get a product in the inventory world because we don't have anything in our database. So again, what I'm going to do is postpone that until after we've done our integration. So once we've done our integration so that when new products are created or they are updated in the catalog service, they end up in the inventory database through integration events, then we'll come back and we'll write a test for our get method there. But the next couple videos are going to focus on just that, the integration events. How do we integrate these 2 microservices so that we get that information about products changing from the catalog world over to the inventory world. So looking forward to it, and I will see you then.
Time for a shameless plug for my personal LLC, Keystone Code. I've been doing software development for 20 plus years now, and I've been lucky enough that I've played a lot of the different roles that go into software development, from back-end developer, front-end developer, full-stack developer, team lead, head of engineering, chief technology officer, business analyst, and architect. So if your agency or company has any needs across those different areas, whether it be a need from just understanding what those roles are, or have a need to fill one of those roles, either from a training perspective, a mentor perspective, or an actual hands-on perspective, feel free to reach out. So I can be reached at my email address, dmichael@keystonecode.com, or on the website at keystonecode.com. Thanks.